Welcome back. The question is, let f is equal to r gives r be the differential function such that its derivative f dash is continuous and f of pi is given as -6. So then find the value of f of 0 if f of x is defined as from 0 to x derivative f of t dt, and if 0 to pi f dash of x plus f of x is into cos x dx derivative is equal to 2. So for that, the given equation f of t derivative, we using Newton's Leibniz theorem, we get f dash of x is equal to f of x, take it as equation 1. And 0 to pi second equation, we can substitute it as f dash of x cos x dx plus 0 to pi of f of x of cos x dx is equal to 2, take it as equation 2. Now using by parts, we can divide the above equation into two parts, that is f dash of x into cos x plus f of x into sin x 0 to pi minus 0 to pi f dash of x sin x dx, that is equal to 2. So which gives an equation of 0 to pi of f dash of x cos x minus f of x sin x whole dx is equal to 2. So we get a derivative of f of x cos x dx from 0 to pi equal to 2. By this we get f of pi derivative dot cos pi minus f of 0 dot cos 0 is equal to 2. By substituting the values of pi and cos, and in the question is given at f of pi is equal to -6, we get -6 minus f of 0 equal to 2. So f of 0 will be equal to 4.